So I think the key issues for soils as we move forward is increasing everyone's understanding about what both the limitations and the opportunities are for individual soils. The greatest challenge I think that we face, no matter where we are in the world, is that people are optimistic by nature. Humans, if we were not optimistic, we wouldn't have gotten to where we are now. The problem is we become over-optimistic in what soils can support. So for example, in the United States, during the early part of the 20th century, we moved out onto lands that ideally, we thought, should be able to support cultivated agriculture. These lands, unfortunately, could not. And when we entered a drought, we suffered some of the worst land degradation and massive social dislocations, termed often as the Dust Bowl. So what we need today is to understand, as we look for more food production, as we look for increased ecosystem services, to understand what those limitations are of the soils, but also what the opportunities are, recognizing that there are many soils that could actually produce more. There are, in fact, many soils that could be restored to support not only food production, but also biodiversity conservation and other ecosystem services. So this, I think, is our greatest challenge, is understanding for a specific location on the landscape, often much smaller than the scale at which we map soils, what those opportunities and limitations are. So I think the key approach, or approaches, I guess, will be those that increase our understanding of land potential, which is understanding both the limitations and the opportunities that each piece of land presents. To understand that, we really need to integrate scientific and local knowledge on a site-specific basis. And today, we have some unique opportunities to do that, which come with the increased adoption of mobile technologies and cloud computing. So today, we no longer have to rely on a soil map and the knowledge that an extension agent or a local farmer might have of an area. We can actually tap into global knowledge simply by identifying the soils that we are on. So, for example, there's a project that's been initiated called the Land Potential Knowledge System, which is designed to do precisely this, to connect people to all of the relevant knowledge and information from around the world that can be applied to determining what the limitations, what the opportunities are, and what some of the unique management solutions might be specific to their soils. So, for example, here at ICRISAT, we have a wonderful display of the different types of soils that one finds in this region. And associated with each of those is our scientific understanding of what the potential of each of those soils is and what the limitations of each of those soils is for production. What it doesn't necessarily include, though, is the local knowledge of how local management systems can, in fact, be adapted and applied both here, but also in other parts of the world where they have very similar soils. For example, in northern Kenya, the soils, in fact, are very similar to the soils that we encounter here. The climate is very similar, and yet different management systems are used. When ideas are generated for innovative ways to manage these soils in Kenya, they should be easily shared with those in Namibia without having to get on a plane. And in fact, through the application of mobile technologies, cloud computing and cloud storage, and through the integration and partnership of multiple institutions like ICRISAT, like ICARDA, like CIAT, like FAO, and of course, like our own national agricultural research organizations, the NARS, in my case USDA, we have a tremendous opportunity to share this knowledge that we have never in the history of humanity had before.